Hey guys, this is Fatma. Welcome to the first ever Excel financial statistics video. Let's get started. I'm going to be completing the table finding the sums, their mean, the sample variance, and the sample standard deviation here in Excel. To find the sum of the x, I'm going to click at the end of the data here and then press Alt equals. In Excel, we'll automatically select the data, the entire data, and then enter will give me the sum of the values. The sum, parenthesis open, select the data, parenthesis close, enter. To find the sample mean, I'm gonna click here, press equals, or I can do equals average, or I can just take the total here and divide by the number of observations or the number of years, which is actually 5. The sum product, the total sum divided by 5, enter. It gives me the sample mean of 0.054. You can increase or decrease up to decimal places on your own. It should be fine. I'm going to increase up to 4 decimal places. Same, I'm going to work out for stock B equals. So parenthesis open, select the entire data, parenthesis close, enter. For the sample mean equals the total sum divided by count, or directly the number of observations as per you like. Select the entire data, parenthesis close, enter. Now for the deviation from the mean, denoted by x minus x bar, this one, that is the distance from the mean, I'm going to type equals 0.190, the actual value, minus the sample mean, 0.054, enter. For I put a log on both sides, press F4, enter. Now click on the bottom right handle over here. When you hold your cursor on it, it will become up, a dark plus sign, and just select. Drag this formula all the way down this way. Yeah, same I'm gonna do for stock B deviations equals the actual value minus the sample mean. Before I put a log on both sides, press F4, enter. Now drag the cursor all the way down. To find the sum, again I'm gonna press equals in Excel. Select the data, close parenthesis. Now enter will give me the sum of 0, nothing. Remember, the sum of the deviations will always be 0 because the positive distance from the mean will always cancel out the negative ones. So that is total distance above the mean must equal the total distance below the mean. Alright, same I'm gonna do for stock B deviations equals sum, parenthesis open, select the data, parenthesis close, enter. Now for the standard deviations, which will be our measure of risk or volatility, I'm going to type equals. I'm going to take the first deviation here and square it, directly, enter. I'm going to grab the handle here and drag all the way down. Same I'm going to do for stock B deviations equals this value, square it, enter, drag cursor all the way down. And for the sum, I'm going to grab this out because it contains the sum formula and just drag it to the right here, and that will give me the sum of the square standard deviations. Same I'm going to do for stock B square deviations, sum, parenthesis open, select the data, and close parenthesis, enter. For the sample variance, I can use the built-in variance function in Excel, or I can just divide the sum of the square deviations by n-1. n-1 is basically 5 equals the total sum divided by 5, enter. That gives me the variance of 0.0131, and for stock B equals the total sum for stock B square deviations divided by 5. 5 is the number of observations, 5, enter. That gives me the variance of 0.0032 For the sample standard deviation, I can use the built-in function, or I can just take the square root of the sample variance equals square root this value, parenthesis close, enter. Same I'm gonna do for stock B, equals square root, parenthesis open, this value, parenthesis close, enter. Now for stock A, 0.1146 and for stock B, 0.0568. Now we'll see by this measure which is the preferable stock. By analyzing that stock A will be more risky and stock B will be less risky. So we are going to prefer stock B. Let's say if investors are risk averse, they'll invest in the less risky stocks rather than the higher risk, for sure. Whereas the risk takers most probably go for the higher risk. Definitely they are going for the higher expected returns. We have already computed the arithmetic mean or the average mean before. I'm going to calculate it again for comparing both these two returns for arithmetic mean and geometric mean returns, that which stock is more desirable. So for arithmetic mean equals the total sum divided by the number of observations, which is 5, enter. Same I'm gonna do for stock B, equals the total sum divided by 5, enter. For the calculations of geo mean, we have to compute from the actual data, change per year, the return per year, period returns. So we have to use the sum product function and then the geo mean. The geo mean need 1 plus all of these rates. Since we actually have the rates, I'm gonna click here at the control shift down arrow equals sum product I'm gonna click here and the control shift down arrow and a +1 parenthesis close, enter. The reason why we have to use the sum product is because we are doing an array operation and normal formulas cannot handle it. So if we slap it into the sum product, that's an argument that says array, it will actually handle the array and we can subtract 1. So I'm gonna add a geo mean, put a geo mean with a parenthesis open, geo mean, parenthesis close, enter. Now that gives a geo mean of 1.0476 for an XYZ company stock. Same I'm gonna do for stock B, equals sum product select the entire data, +1 parenthesis close, and that was the geo mean formula, and you can see there for all of the actual returns or values or changes in percentages or the proportional changes. Now we are going to calculate the expected returns for these particular stocks, and we have some probabilities given. Probability simply means the occurrence or the chances of an event to occur. So there is a 30% probability of 0.10 returns and 10% probability for 0 returns, nothing, and 30% probability for 0.10 returns and 30% probability for 0.25 returns. We're gonna use the sum product two arrays. We simply take our probabilities, comma, and our x values. That's the random variables that can assume a different values, close parenthesis, enter. Comparing to the two arithmetic or average means of the stock A and stock B, I guess stock A is more preferable due to the higher returns on it, and similarly we found the standard deviations of both stocks. So in this scenario we'll definitely prefer stock B because of the fact the higher the standard deviation, the higher the risk. Therefore stock B is more desirable. We also calculated the geometric mean. The greater the variability of return, the greater the differences between arithmetic mean and the geometric mean returns. So we'll go for stop A in the certain scenario. That's it. If you guys like the video, give this video a thumbs up, and if you want more of these videos, stay tuned to the channel and get a financial grasp with me. Catch me up on the next video. See you there. Take care. Bye bye.